Good morning, students. You are welcome to today's class. And if you can remember that for the past 4 weeks now, we have been talking about statics, which is one of the branches of mechanics. And today, we will be looking at dynamics, which simply means forces in motion, which is also one of the branches of mechanics. So, today we'll be looking at momentum. And the learning objective today, at the end of today's lesson, you will learn how to define momentum and how to explain both momentum and change in momentum. Also, you will learn the meaning and the principle of law of conservation of momentum and how you can describe this law and how the law affects in terms of collision. Also, you will learn how to utilize the principle of momentum to solve collision problem for our known collision velocity. So let's go and see. You remember that all objects have mass, and if this object is moving, then we can say this particular object has momentum, which simply means momentum is mass in motion. So by definition, we can define momentum as the product, pay attention to this, as the product of its mass and velocity. That is, momentum is mass and velocity. Mathematically, we can define momentum as P equal to M multiplied by V, where V is the velocity and M is the mass. And don't forget that momentum is a vector product. If that is the case, anytime you are working on momentum, you have to show the sign of vector quantity. So, and the standard unit for momentum is kilometer per second. Remember that momentum depends upon mass and velocity. Let's move forward. So, change in momentum. What do we understand by change in momentum? That change in momentum depends on the force that acts and the length of the time. And we pay attention to the force and the length of time it acts. So in order for an object's momentum to change, there must be a force to be applied for a period of time. Therefore, the change in momentum, which we also know as change in P, can be calculated as follows. So let's see from here that force and time. Force multiplied by time. And if you look at this one properly, you discover that F multiplied by T is the same thing as I, which we call impulse. So don't forget from previous knowledge that force is ma multiplied by T. So from here, I can say that M, do you remember that acceleration is the rate of change of velocity with respect to time? So I can say V minus U all over T multiplied by T. So from here, this T, we cancel this. So we have mv minus U, which is equal to I, and equal to what? Change in momentum. So this formula is telling us that change in momentum is the same thing as impulse. And I want you to know that impulse is not the same thing as momentum, but the same thing as change in momentum. So, using this particular formula. So, let's move forward. Principle of conservation of momentum. There is a principle behind, and the law stated as follows. For a collision to occur between two objects in an isolated system, we are going to learn this in the Google class. The total momentum of the two objects before collision is equal to the total momentum of the two objects after collision. Which simply means momentum lost by a particular object is the same thing as momentum gained by another object. Let's see graphically or pictorially. From here, you can see this particular object in form of a car with mass 1 and velocity 1. Another car moving in the same direction with M2 and V2. If there's going to be collision between the two, then we are going to have M3 and V3. That is to say, the mass and the velocity, the momentum of the first plus the momentum of the second equal to the momentum of the two. So that is that. So let's look at the tips on how to solve problem and momentum. When body collide, the momentum is always constant. Pay attention to that. When we talk about kinetic energy. For body moving and a stationary body, a body and a stationary body, that is a body in rest, we can say M1 V1 equal to V M1 plus M2. Before, this is before and this is after. For two bodies moving, then we can say M1 V1 plus M1 V2 equal to, this is before and this is after. I can say this one before, we can say this one is after. So this is before. Now, the plus sign means the two bodies are moving in the same, initially in the same direction. And the negative sign means the two bodies are moving in what? In opposite direction. So let's go to the Google class to solve example on momentum. God bless you.